In this video, let us continue to solve problems based on graphical method of solving simultaneous linear equations. So we've got a problem here which says solve graphically the system of equations 3x minus y equals 2 and 9x minus 3y equals 6. Well, again, a very similar kind of a problem to the ones that we solved in the previous videos. We've got two equations. All that we have to do is find two solutions for each equation, which will give us a line each for the equations, and then we plot the lines on the graph and see what they do. Do they intersect with each other to show that they've just got one solution, or do they not intersect with each other at all to show that they don't have any solutions at all, or do they coincide with each other, showing that they have infinite number of solutions? Let's see that here. So let's consider the first one, 3x minus y equals 2. And let's have the solution box here. So for this equation, let us first see when x equals 2, what happens? 3 times 2 is 6, so 6 minus y is 2. 6 minus 2 equals y, or y equals 4. So therefore, when x equals 2, you get y as 4. I repeat, you can take whatever value you want for x. Depends on the size of the graph you have. The more bigger you take, the more bigger value you take, the more bigger the graph size that you need to have. Alright, so you get when x equals 2, y is equal to 4. So one more solution is what we need. So let me take when x equals 1, what happens? 3 times 1 is 1, so 3 minus y equals 2. So y equals 3 minus 2, which is equal to 1. So when x equal to 2, y is equal to 1. So when we take x is equal to 1, y is also equal to 1. So when x is equal to 1, y is equal to 1. So we've got two sets of solutions for this equation. Now let us solve this equation similarly. We've got 9x minus 3y equal to 6. Let me draw the solution box here. So x and y. So what I'll do is I'll take x as 0. When I take x as 0, 9 times x is 0. So 0 minus 3y equals 6. Or 3y equals minus 6. So y equals minus 2. 6 divided by 3 is minus 2. So when x equals 0, y is minus 2. Right? So the next one, let us take x as minus 1. What happens when you take x as minus 1? When you take x as minus 1, it becomes 9 times minus 1 is minus 9, minus 3y equals 6, or minus 3y equals 6 plus 9. So y equals 6 plus 9 is 15. 15 divided by minus 3, which is equal to minus 5. So when x equals minus 1, y equals minus 5. So here we've got another two sets of solutions for this equation. So now we're ready to plot the graph. So here we've got the y-axis, then we've got the x-axis. The maximum value is minus 5 that we've got. We'll need that. Alright, so we'll have to divide by 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. And 1, 2, 3, 4, and 5. This is x dash o x, and this is y o y dash. So let us now write the values. 1, 2, 3, 4, 5. It's going to be negative 1, negative 2, negative 3, negative 4, negative 5. This is again going to be negative 1, negative 2, negative 3, negative 4, negative 5. It's going to be positive 1, 2, 3, 4, and 5. So let us start plotting now. We've got, let's first plot 3x minus y equal 2. First point is 2, 4. X is 2 and y is 4, so we've got it here. The second point is 1, 1. This is also 1, this is also 1. Alright, so let us draw this line. So this line represents 3x minus y equals 2. Let's represent 9x minus 3y equals 6. We've got 0, minus 2. X is 0 and y is minus 2. So here we are. And minus 1, minus 5. We've got minus 1 here and minus 5 here. So that should come somewhere here, right? So if you join this, it's gonna go something like this. Or now this line is supposed to join this way. It is supposed to join this red line. If you use a ruler, you will get it accurately, you'll get it precisely. So please do use a ruler to get the straight line. This solution, this line represents 9x minus 3y equals 6. So this solution is a coinciding one. So this is a coinciding one, which means it's got infinite number of solutions. It also means, 2 comma 4 can be a solution, 1 comma 1 can be a solution, 0 comma minus 2, minus 1 comma minus 5. All the solutions that we got here are solutions for these two equations. So let me conclude here saying that this set of equations has infinite solutions. So that's it. This ends this problem as well as this video. I'll see you in the forthcoming videos with more concepts related to simultaneous linear equations.